On June 9, 2026, Anthropic released its newest frontier AI. But they didn't release it as a single product. They took one identical core model and split it into two strictly divided endpoints. The first endpoint is called Mythos-5. This is the raw, unshielded intelligence. Anthropic restricts it exclusively to approved partners within an initiative called Project Glasswing. Because it lacks safety classifiers, Mythos-5 retains its full capacity for zero-day vulnerability discovery and autonomous exploit generation. The second endpoint is Fable-5. It uses the exact same underlying neural network weights as Mythos. However, Fable operates entirely within an aggressive programmatic shield. Anthropic made Fable-5 generally available to the public, but the strictness of these guardrails dictates exactly how developers must structure their API calls. Anthropic has permanently decoupled the model's base intelligence from its safety boundaries. Enterprise developers are now forced to build their applications around heavily guarded endpoints. To understand why Anthropic imposed such an extreme architectural split, we have to look at the severe military and regulatory friction that peaked in early 2026. In February, Defense Secretary Pete Hegseth threatened to cut Anthropic out of the Department of Defense's supply chain entirely. The dispute centered on Anthropic's usage policies. The company refused to lift contractual prohibitions that prevent their models from being used for mass domestic surveillance or fully autonomous weapons. Following this refusal, the Pentagon officially designated the company a supply chain risk, effectively barring U.S. military contractors from doing business with the firm. A month later, a federal judge issued a temporary injunction against the Department of Defense's designation, citing First Amendment retaliation. The sheer weight of this government pressure forced Anthropic into a corner. They had to completely isolate their unrestricted models for specialized cybersecurity use, keeping them far away from their commercial enterprise offerings. Fable-5's heavily restricted API is therefore a direct defensive architectural response to geopolitical friction. This strict security posture extends directly to Fable-5's technical implementation. Specifically, Anthropic immediately deprecated direct reasoning controls. A feature called adaptive thinking is now hard-coded to an always-on state within the API. It cannot be manually bypassed. If we look at the legacy Opus 4.8 API on the left, developers could send raw thinking parameters. On the right, passing a disabled thinking parameter to Fable-5 instantly returns an error. Furthermore, the raw chain of thought is programmatically hidden. The payload will only return output marked as omitted or summarized. Hiding the raw chain of thought prevents attackers from extracting Anthropic's proprietary alignment instructions and classifier rules. To maintain control over the model, engineers must now use high-level effort parameters and allocate specific task budgets to guide the output. Developers no longer prompt the model on how it should reason. They simply allocate the computational budget for its internal cognition. The next major API redesign treats model refusals as a recoverable logic state rather than a terminal network error. Fable-5's biology and cybersecurity classifiers are exceptionally strict. They will inevitably trigger false positives during standard enterprise production workflows. Traditionally, an API refusal results in a hard HTTP 400 or 500 error, which instantly terminates the entire execution chain. Under the new Fable-5 architecture, a refusal by the safety classifier returns a successful HTTP 200 OK status. Inside that successful response payload is a specific key-value pair, stop reason set to refusal. This deliberate design allows client middleware to seamlessly parse the refusal response without crashing the larger application. Using a native fallbacks parameter, blocked requests are automatically rerouted to a legacy model like Opus 4.8. To incentivize this architecture, Anthropic automatically refunds the prompt cache token cost of the switch when this fallback route is triggered. Anthropic engineered a system where high-friction alignment is financially subsidized. This makes strict safety bounds economically viable for maintaining enterprise uptime. These complex workflows are necessary because Fable-5 is built for long-horizon edge-and-tick execution, which justifies its premium pricing tier. The raw specifications driving this autonomy include a 1 million token context window and a maximum output limit of 128,000 tokens. We can see how this operates in practice by examining software developer Simon Willison's recent work. He utilized Fable 5 to build a WebAssembly-based Python sandbox. The core challenge is that long-horizon autonomy requires human-in-the-loop approval breaks. The model must ask for permission before executing certain scripts. To handle concurrent tool execution securely, Fable 5 assigns a unique tool pol ID to each operation, using synthesized ULIDs with a TC prefix. Willison's library implements a specific pause chain exception to manage these IDs and handle human-in-the-loop approval. During the pause phase, the system executes an asynchronous tool, catches the exception, holds the state in place, and waits indefinitely for user input. Once approved, the resumption phase begins. The message's array history resumes execution exactly where it left off, without dropping any unresolved pending sibling tool calls. Building for Fable 5 requires an operational shift. Engineers must move away from linear, synchronous scripts and instead construct asynchronous, state-holding agent loops that actively anticipate human intervention. With Fable 5, direct access to raw model weights has been replaced by a mandatory system of safety classifiers and restricted endpoints. Foundation models can no longer be treated as simple text-in, text-out utilities. The new engineering standard requires optimizing high-level task budgets instead of manually formatting direct reasoning prompts. Architecturally, systems must be robust enough to handle stateful HTTP 200 refusals and run complex, interruptible pause and resume toolchains. While the raw intelligence found in Mythos remains unchanged, the commercial deployment vehicle we access through Fable operates under strict programmatic containment. As model behavior is increasingly governed by these external layers, the developer's role moves toward programmatically mastering the boundaries of the API environment itself.